To reap the benefits of a massively large-scale supercomputer, there are some basic principles that you need to follow under the hood. Let's take a look at the magic sauce that allows the high performance in high-performance computing. Since this is an introductory chapter, we're not going to go into significant depth in this morsel. The concepts that we are covering will also be covered in a later chapter, but you need to have some exposure to these concepts from the start, or you'll miss the important role that they play in an HPC system. For all of these examples, any activity being performed by a person is an equivalent of a processing element in a CPU. Time for a quick quiz. If we were to have a gigantic desktop PC that had a theoretical equivalent performance, think R peak, of an HPC system, would it perform equivalently? And your options are yes, no, it depends. Actually, it's not even possible. And the answer is, it depends. We can't say that it will perform equivalently. We can't flat out say that it won't. It depends. And that's where serial and parallel execution come in. And these concepts hold true for any modern computing device. Let's dive in. The first concept, and likely the one you're familiar with without necessarily knowing its official description, is called serial execution. What this means is that a problem is taken from start to finish. If it had 3 billion instructions, a 3 gigahertz CPU would take 1 second to complete it. If it had 30 billion instructions, then a 3 gigahertz CPU would take 10 seconds. In that case, each time step is 3 billion instructions, which is 1/10 of the total. The CPU wouldn't do anything else besides that problem. That is performing in serial. Probably a good real-life example of this would be standing in a queue for coffee. It's one person at a time waiting for their order to be taken, for the coffee to be prepared, and then for it to be served. Understandably, a computer doesn't actually ever try to do one thing at a time. Even listening to this video involves your computer processing a video, processing the audio, streaming the data to you, outputting the data to your screen, reading inputs from you such as your keyboard to tell it to accelerate or skip to the next video, and so on. It's not doing one explicit thing at a time, and we'll get into a bit more about that later. On the other hand, parallel execution is taking that same serial problem we just spoke about and breaking it into pieces that can each be processed independently. Back to the coffee example, if you're ordering coffee, think of it that there are now 3 queues with 3 staff members and 3 coffee machines. You can make up to 3 coffees at the same time. In the case of that 30 billion instructions, if you had 3 gigahertz CPUs, it would take 1/3 of the time of a single CPU to process the problem if it was done purely in parallel. Now the tricky one is concurrency. And concurrency is a much more challenging concept to understand, but probably what you can get from the start is that it is not that concurrency called Bitcoin or Dogecoin or whatever. Consider concurrency as the middle ground between serial execution and parallel execution. It is serial behavior creating the illusion of parallel behavior. Concurrency is the approach of splitting your time between multiple tasks. You aren't working on multiple things at once, you're just splitting your focus. In this example, an example of concurrency is one person taking orders and serving the food. There are 2 queues, but with only one person serving both, you might think that things are going in parallel, but they're actually only going as fast as one person can switch between the 2 queues. On the other hand, a parallel version of this example would be 2 people, one person serving each queue, one for orders and one for collections. And of course that old mantra, parallelize versus parallelize. It's the matter of trying to throw too many processing elements into a single task. For example, you've all heard that expression, too many cooks spoil the brothel. Well, in this example, if you have too many cooks in this kitchen, they're going to bash into each other, fight over the utensils, interfere with the correct order of things, and so on and so forth. So it can actually make the performance worse, or actually even produce the wrong result entirely. On one hand, you might be able to start over, but on the other hand, you might have a deadlock for 2 people fighting over the spoon, and nothing actually gets anywhere. In other words, you've experienced paralysis.